All right, everybody. Section 2.2, organizing qualitative data. Notice that's we're talking qualitative, so non-numerical things, right? So first and foremost, we're going to talk about distributions. Distributions. All right. So a frequency distribution is a listing of distinct values and their frequencies. So, in other words, when I say frequency, I'm not talking about a radio frequency. Okay, when I say frequency, I'm talking about how many times they occur, how many times something occurs. So, with your, as you're taking notes, hopefully, while you're using this frequency, how many times something occurs. How many times something occurs. Okay. So, to construct a frequency distribution of qualitative data, list the distinct values of the observation in the data set in the first column. For each observation, place a tally mark in the second column. Count the tallies for each distinct value and record the totals in the third column. Okay? I mean, this is pretty basic in terms of what we're doing. Okay, so Professor Francis asked his class to state their political affiliation. The parties is what it should say, are listed in the following table. Democrat is D, Republican is R, O is other. Make a frequency distribution for the class's responses. Okay, so a frequency distribution. So we're going to make our table here. Let's use yellow. Let's change it up a bit. All right, so we're going to make our table here. And in the first column, we're going to have the party. In our second column, we're going to have our tally marks. And in the third column, we're going to have our frequency. Okay, so you've got Democrat, Republican, other. So let's count. In the first row there's one Democrat. In the second row, there are 1, 2, 3 Democrats. In the third row, there's 1, 2 Democrats, so that would be 5. In the fourth row, there are 1, 2, 3, 4, 5 in the fourth row alone. Okay, and in the last row, there are 2. Let's make sure I didn't miscount any here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I did. I miscounted one. Always double check as you're making tally marks like that. You can miscount. So there are 13 Democrats. Let's do the same thing for Republicans, and what you will find out is there are 18 Republicans, and there are 9 others. So when you get after you get your tally marks in here, go over here, count them up, and that's your frequency. So we have 13, 18, 9, and that's of course a total of 40. Okay, so this is what I mean by making a frequency distribution. It's pretty simple. A lot of people like this. Um, so if you have any questions, make sure you ask your professor on that. All right, so let's take it a step further and talk about relative frequency. That's the frequency over the total number of observations. You can relate this as a percent or as a decimal. So, for instance, for example 1, we had, for the example we just did, if you look at the frequency of Democrat, what's the relative frequency of the Democrats? Okay, What is the relative frequency of the Democrats? Well, relative frequency. Well, it's frequency over total number of observations. Well, there were 40 total observations, and we counted that there were 13 Democrats. So that would be a 0.325. So that, or 32.5%. Either way. I prefer the 0.325, but 32.5% will work. Just read your directions. Make sure on your homework, because it will tell you what it wants you to express it in. It actually prefers. I'm okay with the percent, but it actually prefers relative frequency as 0.325 because it's trying to add everything up out of 1. So let's just go ahead, as I said in this last sentence, let's just go ahead and express it as 0.325 unless otherwise asked. Okay, unless otherwise asked. If it allows you to put it as a percentage, that's fine. But let's put it like that unless otherwise asked. All right, so we can go along with what our book says. All right, so a relative frequency distribution of qualitative data is a listing of the distinct values and their relative frequencies. So to construct a relative frequency distribution table, we construct a frequency distribution table just like we did, but the only difference is we divide the frequencies by the total observations. All right, so for example, find the relative frequency of example 1. Well, here's our table. So all we would have to do here, is add another column, relative frequency. And so just take each of our frequencies there and divide it by 40. 18 divided by 40, 9 divided by 40. And what that is going to give us here, 13 divided by 40 we said was 0.325. 18 divided by 40 is 0.45. And 9 divided by 40 is 0.225. Now, what you should notice, if you've done this relative frequency correct, you should come out with 1 at the end. So, as I said, in terms of percents, that's 100%, that 1 at the end. So, how would we interpret this? Well, we could say 32.5% of the people are like Democrats, 45% like Republicans, and 9%, excuse me, not 9%, 22.5% were others. And here's a little side note. Relative frequencies are a lot better than frequencies for comparing data sets. Relative frequencies often fall between 0 and 1. They provide a standard for comparison because it's basically telling you what percent of the total something is making up. So it's allowing you to compare in something that we understand, which is percent, decimals and percent. So it's a lot better than frequency. So you're going to probably be asked for relative frequency more than you would frequency alone. Because when you're counting, really and truly, what does counting end up in? That really doesn't tell you much, but a decimal or percent out of 1 or 100% does tell you a lot about something. Because if you look back at this, it tells you, if I know the decimal percent of this, 32.5%, 45%, and 9%, I can tell you a lot about about who's getting closer and how close they are and who's the majority. Now you can do that with a little bit with frequency, but the percent allows you to do it in a much more comparative way. All right, so pie charts and bar charts. To construct a pie chart, obtain relative frequency, divide the disk into wedge shape proportional to the relative frequencies, and label the parts of the pie with their distinct values. Okay, so for instance, for instance, if we were to, let me make sure we're not going to do an example. No, we're not. Let's go back and let's start from right there. Okay, so let's think about our data that we just got finished doing. So we had Democrats 32.5%. We had Republicans at 45%, and we had other at 22.5%. Okay, so we've obtained the relative frequency. So let's draw our pie. So 45%, that's not quite 50%, so I'm going to draw it just a shade less than 50. That's my Republicans, that's 45%. And then 32% is greater than 22%, so by 10%, so we need it to be a good deal larger than the other. So here's our Democrats, so that's 32.5% and 22.5%. Now, if you're really good with your Microsoft Excel, it will draw these for you. However, don't get in the habit of that. I will not allow you, or your instructor will not allow you to use Excel on the exams. So don't get in the habit of using Excel to get all of your. Don't get in the habit of using Excel to get all of your answers. You need to either know how to do it with your calculator and use that to help you draw it, or know how to work it out by hand. Okay, so keep that in mind. I don't want you to develop a crutch and then it come back and break on you at the midterm and final. Okay, so keep that in mind. Just looking out for you. All right, so there's your pie chart. All right, what about the bar chart? Well, you can obtain the relative frequencies, draw and label the horizontal axis to place the bars, and the vertical axis to place the frequencies. And for each distinct value, construct a vertical bar. Okay, so for instance, if we were to do our data that we just got finished doing, we could have Democrat, Republican, other. This is 0, 0.2, 0.4, 0.6, 0.8, and 1. Okay? And so we have a Democrat that's 32.5. So 32.5. And of course, you can shade that in if you want to. We have a Republican that's 45%, or 0.45. So that's a little taller than that. And we have an other that's 22.5. So it's going to be about right there. Now, again, you can use Excel to help draw this for you, but be able to do this by hand and pick it out for exams, because I don't believe I make you actually physically draw any on an exam, but you will have to be able to know what it looks like and be able to pick it out. So be able to do that. Don't let Excel be a crutch for you. That's what I find a lot of people try to do, and then when they get to exams and can't use it, they fall apart. So don't get in that habit, okay? I want you to know it ahead of time. If you know it, it doesn't matter whether your technology goes down or not. You're still going to be able, if you know how to do it by hand, you're still going to be able to do it, okay? So that's a little word to the wise there. As I said, just kind of looking out for you and what's best for you. All right? Now, that ends section 2.2. At the end of these sections that we're doing now, you'll have a technology section that will explain how to use it in Excel, that will explain how to use it in Minitab and the graphing calculator, I would I would do it in the graphing calculator. I would learn out of all the technology things that you need to learn. I would make sure and learn the calculator parts of it before I would learn Excel or anything like that. So keep that in mind. Um, just because it says it in the book doesn't necessarily mean you're going to get to use it on the exam. So you will get to use the graphing calculator, but you will not get to use Microsoft Excel or Minitab on your exam. So keep that in mind as you're going through these technology sections. And have a great day.